NEC 220.33 addresses other outlets not used for lighting or general use receptacles. NEC 220.34 covers outlets not used for lighting or general use receptacles, but used only for appliances in a dedicated space for particular equipment. General lighting and general use receptacles, as defined by NEC 220.32, include lighting outlets and convenience receptacles intended for general use. Based on these definitions, appliances such as vent hoods, ceiling fans, heating, ventilation, and air conditioning blowers, refrigerators, garage door openers, and bath exhaust fans should not be neglected as being included in the general lighting and general use receptacles calculation of 220.32. These appliances are not used for general lighting and are intended for specific purposes. Therefore, they should be included in the calculations for other outlets not used for lighting, as per 220.33m4. For dedicated appliances or appliances in a dedicated space, the 3 volt amps per square foot general lighting and general use receptacles requirement does not apply. When calculating the electrical load for a dwelling or building, it's crucial to account for all significant electrical devices and outlets. The National Electrical Code, or NEC, provides guidelines to ensure safety and prevent overloading the electrical system. One area that often requires clarification is how to handle various appliances and outlets beyond general lighting and receptacles. We need to look at the distinction between general use outlets and those dedicated to specific appliances, as well as the implications for load calculations. General lighting and general use receptacles are typically covered under a standard allowance and load calculations, usually expressed in volt amps per square foot. This allowance is intended to cover typical lighting needs and the use of common plug-in devices. However, certain appliances and outlets fall outside this category and require separate consideration. Vent hoods, also known as range hoods, are typically installed above cooking ranges or stoves to remove smoke, grease, and odors from the kitchen. They are dedicated appliances with specific power requirements and should not be included in the general lighting and receptacle allowance. Ceiling fans are used for air circulation and often include lighting fixtures. While the lighting portion might be considered under general lighting, the fan motor itself represents a separate load that should be accounted for. Heating, ventilation, and air conditioning, or HVAC, blowers are essential components of climate control systems. They consume significant power and must be included in the load calculation, typically as a dedicated circuit or appliance. Refrigerators are continuous use appliances with substantial power demands. They are not covered by the general receptacle allowance and should be considered separately. Garage door openers are motor-driven devices used to open and close garage doors. They have specific power requirements and should be included in the load calculation. Bath exhaust fans are used to remove moisture and odors from bathrooms. Like vent hoods, they are dedicated appliances that should be accounted for separately. The NEC provides specific guidance on how to calculate the load for these types of appliances and outlets. Generally, the nameplate rating of the appliance should be used to determine its power consumption. This rating is usually expressed in watts or volt amps and can be found on a label attached to the appliance. For appliances with intermittent or non-continuous loads, the NEC may allow for demand factors to be applied. Demand factors are percentages that reduce the calculated load based on the likelihood that all appliances will not be operating at their maximum power simultaneously. However, it's crucial to apply demand factors cautiously and in accordance with the NEC guidelines. Failure to properly account for these appliances and outlets can lead to underestimation of the total electrical load, which can result in overloaded circuits, trip breakers, and potentially hazardous conditions. It's always recommended to consult with a qualified electrician or electrical engineer to ensure accurate load calculations and compliance with the NEC. Remember that electrical codes and regulations may vary depending on the specific location, so it's essential to refer to the local electrical code for the most accurate and up-to-date requirements. By understanding the distinction between general use outlets and dedicated appliance outlets, and by following the NEC guidelines for load calculations, you can ensure the safety and reliability of your electrical system. Let's delve deeper into the specific sections of the National Electrical Code that address these considerations. NEC 220.30 provides methods for calculating feeder and service loads for dwelling units. It outlines different approaches for determining the total electrical load based on various factors, including the size of the dwelling, the number of appliances, and the type of heating and cooling systems. Subsection B of 220.30 focuses on the optional calculation for dwelling units. This method allows for a more detailed assessment of the electrical load by considering specific appliances and equipment. Paragraph 2 of 220.30 addresses general lighting and general use receptacles. It specifies a minimum load of 3 volt amps per square foot to cover lighting outlets and convenience receptacles intended for general use. This allowance is designed to accommodate typical lighting needs and the use of common plug-in devices. Paragraph 3 of 220.30 covers other outlets not used for lighting or general use receptacles. This category includes outlets dedicated to specific appliances, such as those mentioned earlier, including vent hoods, ceiling fans, HVAC blowers, refrigerators, garage door openers, and bath exhaust fans. These outlets must be calculated separately based on the nameplate rating of the appliance or the connected load. Paragraph 4 of 220.30 addresses outlets not used for lighting or general use receptacles but used only for appliances in a dedicated space for particular equipment. This provision applies to situations where an appliance is located in a specific area and is intended for a particular purpose, such as a laundry room or a home office. In these cases, the load for the appliance should be calculated separately and not included in the general lighting and receptacle allowance. It's important to note that the NEC allows for demand factors to be applied to certain loads, as specified in Article 220. Demand factors are percentages that reduce the calculated load based on the likelihood that all appliances will not be operating at their maximum power simultaneously. For example, the NEC may allow a demand factor of less than 100% for certain cooking appliances or heating and cooling equipment. However, it's crucial to apply demand factors cautiously and in accordance with the NEC guidelines. Overly aggressive use of demand factors can lead to underestimation of the total electrical load and potential safety hazards. In addition to the specific requirements outlined in 220.30, other sections of the NEC may also be relevant to appliance load calculations. For example, Article 422 covers the installation and wiring of appliances, including requirements for overcurrent protection, grounding, and disconnecting means. Article 430 addresses motors and motor-operated appliances, including requirements for motor circuit conductors, overload protection, and control circuits. It's essential to consult these articles and other relevant sections of the NEC to ensure compliance with all applicable requirements. When performing appliance load calculations, it's helpful to create a detailed inventory of all electrical devices and outlets in the dwelling unit. This inventory should include the nameplate rating of each appliance, the type of outlet, and the location of the device. Using this information, you can systematically calculate the load for each appliance and outlet and determine the total electrical load for the dwelling unit. It's also advisable to use a load calculation worksheet or software to help organize the calculations and ensure accuracy. These tools can automate many of the calculations and provide a clear summary of the total electrical load. Remember that electrical codes and regulations are subject to change, so it's essential to stay up to date with the latest requirements. The NEC is typically updated every 3 years, so it's crucial to use the most recent edition of the code. In addition to the NEC, local electrical codes may also impose additional requirements or restrictions. It's always recommended to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. By understanding the specific requirements outlined in the NEC and by following best practices for appliance load calculations, you can ensure the safety and reliability of your electrical system. This will help prevent overloaded circuits, trip breakers, and potentially hazardous conditions. Let's now consider some practical examples of how to apply these principles to real-world scenarios. Firstly, consider a kitchen renovation project where a new vent hood is being installed above a cooking range. The vent hood has a nameplate rating of 250 volt amps. According to the NEC, this load must be calculated separately and not included in the general lighting and receptacle allowance. Therefore, an additional 250 volt amps must be added to the total electrical load for the kitchen. Secondly, imagine a homeowner is installing a new ceiling fan with a light fixture in a bedroom. The ceiling fan motor has a nameplate rating of 75 watts, and the light fixture has a rating of 60 watts. While the light fixture may be considered under general lighting, the fan motor represents a separate load that should be accounted for. Therefore, an additional 75 volt amps should be added to the total electrical load for the bedroom. Thirdly, suppose a homeowner is adding a new refrigerator to their kitchen. The refrigerator has a nameplate rating of 150 watts. This appliance is not covered by the general receptacle allowance and should be considered separately. Therefore, an additional 150 volt amps must be added to the total electrical load for the kitchen. Fourthly, consider a homeowner is installing a new garage door opener in their garage. The garage door opener has a nameplate rating of 1/2 horsepower. To convert horsepower to volt amps, we can use the following formula: volt amps equals horsepower times 746 watts per horsepower. In this case, 1/2 horsepower times 746 watts per horsepower equals 373 volt amps. Therefore, an additional 373 volt amps must be added to the total electrical load for the garage. Fifthly, imagine a homeowner is installing a new bath exhaust fan in their bathroom. The bath exhaust fan has a nameplate rating of 50 watts. This appliance is a dedicated appliance that should be accounted for separately. Therefore, an additional 50 volt amps must be added to the total electrical load for the bathroom. In each of these examples, it's crucial to accurately determine the nameplate rating of the appliance and to include that load in the total electrical load calculation. Failure to do so can lead to underestimation of the total load and potential safety hazards. In addition to these specific examples, it's also important to consider the impact of other electrical devices and outlets on the total electrical load. For example, if a homeowner is installing a new electric water heater, the load for the water heater must be calculated separately and not included in the general lighting and receptacle allowance. Similarly, if a homeowner is installing a new electric range or oven, the load for the range or oven must be calculated separately and in accordance with the NEC requirements. When calculating the load for these types of appliances, it's essential to use the appropriate demand factors as specified in the NEC. Demand factors can significantly reduce the calculated load, but it's crucial to apply them cautiously and in accordance with the NEC guidelines. In conclusion, appliance load calculations are a critical aspect of electrical design and installation. By understanding the specific requirements outlined in the NEC and by following best practices for load calculations, you can ensure the safety and reliability of your electrical system. This will help prevent overloaded circuits, trip breakers, and potentially hazardous conditions. Always consult with a qualified electrician or electrical engineer to ensure compliance with all applicable codes and regulations. Let's shift our focus to the practical application of the NEC guidelines in various scenarios, specifically concerning the inclusion or exclusion of certain appliances from the general lighting and general use receptacle load calculation. To reiterate, the general lighting and general use receptacle load is typically calculated at 3 volt amps per square foot, as per NEC 220.32. This allowance covers the majority of lighting and small appliance usage in a dwelling. However, certain appliances, due to their specific nature and higher power demands, require separate consideration under NEC 220.33 and 4. Consider a scenario where a homeowner is adding a new kitchen island. The island includes several receptacles for countertop appliances, such as blenders, toasters, and coffee makers. These receptacles are considered general use receptacles and would typically be included under the 3 volt amps per square foot allowance. However, if the kitchen island also includes a built-in microwave oven, the microwave oven would need to be calculated separately, as it is not considered a general use receptacle. The nameplate rating of the microwave oven would be used to determine its load, and this load would be added to the total electrical load for the kitchen. Now, let's consider a scenario involving a home office. The home office includes several receptacles for computers, printers, and other office equipment. These receptacles are considered general use receptacles and would typically be included under the 3 volt amps per square foot allowance. However, if the home office also includes a dedicated server or a large uninterruptible power supply, the server or uninterruptible power supply would need to be calculated separately, as it is not considered a general use receptacle. The nameplate rating of the server or uninterruptible power supply would be used to determine its load, and this load would be added to the total electrical load for the home office. Moving on to a laundry room scenario, the laundry room includes receptacles for a washing machine and a dryer. The washing machine is typically considered a general use receptacle and would be included under the 3 volt amps per square foot allowance. However, the electric dryer is a high-power appliance that requires separate consideration. The nameplate rating of the electric dryer would be used to determine its load, and this load would be added to the total electrical load for the laundry room. Gas dryers, on the other hand, typically have a much lower electrical demand and may be included under the general use receptacle allowance depending on their specific power requirements. In a bathroom scenario, the bathroom includes receptacles for hair dryers, electric shavers, and other personal care appliances. These receptacles are considered general use receptacles and would typically be included under the 3 volt amps per square foot allowance. However, if the bathroom also includes a whirlpool tub with a dedicated pump motor, the pump motor would need to be calculated separately as it is not considered a general use receptacle. The nameplate rating of the pump motor would be used to determine its load, and this load would be added to the total electrical load for the bathroom. Considering outdoor scenarios, outdoor receptacles are typically used for landscape lighting, holiday decorations, and power tools. These receptacles are considered general use receptacles and would typically be included under the 3 volt amps per square foot allowance, assuming they are not dedicated to specific appliances. However, if the outdoor area includes a swimming pool with a dedicated pump motor and heater, the pump motor and heater would need to be calculated separately, as they are not considered general use receptacles. The nameplate ratings of the pump motor and heater would be used to determine their loads, and these loads would be added to the total electrical load for the outdoor area. In summary, the key factor in determining whether an appliance should be included under the general lighting and general use receptacle allowance or calculated separately is its specific nature and power demand. Appliances that are considered general use and have relatively low power demands can typically be included under the 3 volt amps per square foot allowance. However, appliances that are dedicated to specific purposes and have higher power demands require separate consideration and must be calculated based on their nameplate ratings. It's important to carefully evaluate each appliance and outlet to determine its appropriate classification and to ensure accurate load calculations. Consulting with a qualified electrician or electrical engineer can help ensure compliance with the NEC and prevent potential safety hazards. Furthermore, let's consider the implications of dedicated spaces and their impact on appliance load calculations. According to NEC 220.34, outlets not used for lighting or general use receptacles but used only for appliances in a dedicated space for particular equipment are treated differently. A dedicated space is an area specifically designed and used for a particular purpose, such as a home theater, a workshop, or a server room. In these cases, the 3 volt amps per square foot allowance for general lighting and general use receptacles does not apply. Instead, the load for the appliances in a dedicated space must be calculated separately based on their nameplate ratings. For example, consider a home theater with a projector, a sound system, and a media server. The projector, sound system, and media server are all dedicated appliances used specifically for the purpose of a home theater. Therefore, the 3 volt amps per square foot allowance does not apply, and the load for each appliance must be calculated separately based on its nameplate rating. Similarly, consider a workshop with a table saw, a drill press, and a grinder. The table saw, drill press, and grinder are all dedicated appliances used specifically for the purpose of the workshop. Therefore, the 3 volt amps per square foot allowance does not apply, and the load for each appliance must be calculated separately based on its nameplate rating. The concept of dedicated spaces is important because it recognizes that certain areas have significantly higher electrical demands than typical living spaces. By treating these areas differently, the NEC ensures that the electrical system is adequately sized to handle the load. It's important to note that the definition of a dedicated space is somewhat subjective and may vary depending on the specific application. Generally, a dedicated space is an area that is clearly defined and used primarily for a single purpose. However, if there is any doubt about whether an area qualifies as a dedicated space, it's always best to consult with a qualified electrician or electrical engineer to ensure compliance with the NEC. In addition to the specific requirements for appliance load calculations, it's also important to consider the overall design and layout of the electrical system. The electrical system should be designed to provide adequate power to all areas of the dwelling, while also ensuring safety and reliability. This includes properly sizing conductors, selecting appropriate overcurrent protection devices, and providing adequate grounding. It's also important to consider the potential for future expansion and to design the electrical system with sufficient capacity to accommodate future needs. This can help avoid costly upgrades or modifications in the future. Finally, it's essential to document all electrical calculations and design decisions. This documentation should include a detailed load calculation, a wiring diagram, and a list of all electrical components. This documentation can be valuable for future maintenance, troubleshooting, and upgrades. By following these guidelines and by consulting with qualified professionals, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations.